Okay, let us discuss this problem. Let me first make the diagram. And let us see what this question says. Two particles each of mass m are joined by a light and rigid rod of length a. So these are two particles that is connected by a light rigid rod. This is massless. One particle rests on a horizontal smooth plane. So this is a horizontal smooth plane, that is mu is equals to 0. Now question says the upper particle is given a small displacement, so the rod starts to fall. So this has been given a small push. Due to this small push, this system starts to fall. So that when inclination is 60 degree, so after some time what you will have, so you will see, so initially system is here. After some time you will see this has basically moved in this direction. So initially system is here. After some time you will see this system has moved in this direction, as well as this has rotated. Are you getting? So this is going, and this time question says if the inclination from the vertical is theta, that is 60 degree. So when the inclination is 60 degree, you have to find what is the velocity of lowest particle, the lower particle. So we have to find, or velocity of, basically you have to show that velocity of lower particle is given by under root GL by 14, GA by 14. Now let us try to see what is happening in this case. Once you give a small push, this will start fall this side, but this will slip this side. So now I can see this system can be composed of two kind of motion, translation plus rotation. Now see this mass, so I can assume the center of mass is going this side with a speed u. So my center of mass is going this side with a speed u. This means this mass is going this side with a speed u. This mass is also going this side with a speed u, because center of mass is rotating, translating this direction with a speed u. So this and this both are going with a speed u in this direction. Now this is basically also rotating. So let us say this is rotating. So this angle is theta. This system is rotating about this point. This point is in the rest. So instantaneous axis of rotation, you see this whole system is rotating about this point. So it will have a velocity component, so omega I will have. So due to this omega, you will have a omega velocity. So let us say basically a omega I can write in terms of v. So it will have a velocity v is equal to a omega. So let us simply write it will have a velocity capital V, and that is basically equals to a into omega. Now let us write component of a omega in two direction, or I can find the total velocity. So component of a omega will be in this direction. We will have, so this angle is theta, so this angle has to be theta. 90 minus theta, this angle is theta. Are you getting? So let us verify yourself. This angle has to be theta. This is theta, theta, 90 minus theta, theta. So this is b cos theta. And this side we will have b sin theta. So total velocity of this mass, the upper mass, I will have total velocity of upper mass is given by bx square plus vy whole square. Bx is let us say this is my positive x-axis and this is my positive y-axis. Are you getting? So I will have total velocity will be vx square, that is v cos theta minus u whole square plus vy whole square, and vy is v sin theta, so v sin theta whole square. Are you getting? I can also write in a general way, so this is v cos theta whole square plus v sin theta whole square, so this is v square plus u square minus 2uv cos theta, and this is my resultant velocity. Let us apply two equations. First I will apply momentum conservation equation, so I can write first equation for momentum conservation. So if I apply momentum conservation, initially system has in the rest in the x direction, so there was no momentum in the x direction. There is no force acting in the x direction, so f external fx is 0, so I can always apply momentum in the x direction is 0. So let us write what is the total momentum in the x direction. So this mass is going with the speed u, so mu, and so this is mu, but this is going this side, so I will have to apply a minus sign. For this, in the x direction velocity is v cos theta minus u, so momentum will be m plus v cos theta minus u. This is equals to 0. So from here you will have m goes out, so you will have 2u is equals to v cos theta. Now in a special case we have to find only for theta is equals to 60 degrees, so cos 60 is 1 by 2, so this becomes 4u is equals to v. If I plug the value of cos theta equals to 60 degrees, so my answer we have to find for cos theta is equals to 60 degrees. If I plug theta equals to 60 degrees, so cos theta is 1 by 2, so this is v is equals to 4u. So let us say this is my equation number 1. And the second equation I am going to get from energy conservation, because system has no dissipative force, so I can always apply energy conservation. So if I apply energy conservation, you see what is the loss in potential energy. So now I am going to write energy conservation in this form. Loss in potential energy is equals to gain in kinetic energy. Are you getting? So let us say what is the loss in potential energy. So this system is here initially. Now it has fallen through this distance. So this distance was A. Let me make another diagram so that you don't have any confusion. Are you getting? So loss in potential energy is equals to gain. You can write yourself if you want. So initially the system is here. Now, so this has basically fallen something like this. So this is the loss in potential energy. So this height is initially A. Now this height is A cos theta, because this angle is theta. This length is A. So this length will be A cos theta. So this change in potential energy, so this is the loss, that is A minus A cos theta. So this is the loss in potential energy, A minus A cos theta. This is a loss in height. Are you getting or not? So what is the loss in potential energy? I can say, well, if this mass has lost potential energy, mg A minus A cos theta is equals to gain in kinetic energy. So this mass has a speed u, half mu square plus a half m. For this mass, we have already calculated velocity for this mass. So you see, this velocity is v square plus u square minus 2uv cos theta, and cos theta is 60 degree. So I can write, so let us plug this value for v square, resultant velocity, that is v square plus u square minus 2uv, and if I plug cos theta is 60 degree, cos 60 degree is 1 by 2. Are you getting? So what you will have? You will have m goes out throughout. So g into a minus a cos theta, 2 multiplied this side, you will have u square plus v square plus u square minus 2 into 2 4uv. Now I have to find u. So let us say you have one equation here, that is the relationship equation number 1, 4u is equals to v. So you can apply this one. So 4u is v. So let us say this 4 is equals to v. So I have to find u. So let us do this one. And cos theta is 60 degree. So 1 by 2. So 1 minus 1 by 2. So this will be simply 2z a into 1 by 2. I think you are able to understand. This is equals to u square plus v square will be 4u square. So 4u square, this is 16u square plus u square, and minus 4uv. So u is u and v is 4u. Basically in this step, this 1 by 2 goes out, so there will be no 4. So there will be no 4 here. Are you getting or not? So this cos theta is 1 by 2. So 1 by 2 goes. So we will simply have u into v. So u into v will have. So this side you have GA. This is equals to u square plus 16 plus 1 17 minus 4. So 13. So this is 13 u square. So you will have 14 u square is equals to GA. So u is basically GA by 14 under root. Are you getting? So this in this question, important point we have, once we have given a push, I have to analyze the motion in two parts, rotation as well as translation. I have assumed the center of mass is translating with the speed u, and system is rotating about the lowest point with velocity omega. And so if the omega is the lowest point velocity, so tangential velocity of this point will be a into omega. That the tangential, because this point is rotating about this point, so tangential velocity will be a into omega, and let us call that a omega as capital V. Now I have to break this V into two components, Vx and Vy, and then after breaking the component, things are very easy. I have to apply two equations, energy conservation and momentum conservation in the x direction, and then I have to solve the equation. So not much important point we have in this question. Only important point we have, that is analyzing the motion in two ways. So dividing the motion in two parts, translation as well as rotation. And once you have done this, everything is simple. Another important point for this is the resultant velocity. Sometimes people gets confused. Resultant velocity. So you have to have resultant velocity is Vx square plus Vy square. So Vx is u minus b cos theta, or b cos theta minus u if you take on this side positive, plus b sin theta whole square. So resultant velocity is also important. Many people confuses these ideas. We'll discuss the next problem.